Two 10-Newton forces act concurrently on a point at an angle of 180 degrees to each other. The magnitude of the resultant force of the two forces is, so when you have two 10-Newton forces acting at an angle of 180, okay, acting at an angle of 180 degrees, what will be the resultant of these two forces? Anna, this question is yours. We have two 10-Newton forces acting at an angle of 180 degrees to each other. What will be the resultant? Anna, don't waste time. Let's quickly hear from you. Okay, if Anna is not here, Imelda, what will be the resultant in this case?
That 14.1.
14.1. And do you have your answer in the options that was given? Okay, Frank, what will be the resultant in this case? Frank. Hey, when you are called, please do not waste time. Okay, anybody to try? Anita.
Please 20.
20. Augustine, Anita, sorry. Augustine is also saying that the answer is 0. Hey, interesting answer. So, okay, this is my verdict. When you have two 10-Newton forces, okay, acting in this manner, let me give a quick sketch of the situation. So you have two forces of the same magnitude acting oppositely to one another. So 10-Newton, another 10-Newton. This angle between them, we are told, is, this cannot be, this angle is 180 degrees. Yes, if two forces or vectors act oppositely to one another, the resultant is subtracting the smaller vector from the bigger one. So this formula is on condition that F1 is greater than F2. But here is the situation, and this applies to when they are oppositely to one another. And when they are oppositely directed, the angle between them is 180. So once we have F1 being equal to F2, Imelda, what will be the resultant? If F1 is equal to F2, what will be the resultant?
0.
It's 0. So 0.00 Newton. So the first option, 1. All right, question 47. A force of 3 Newton and a force of 5 Newton act concurrently to produce a resultant of 8 Newton. So 47, we have 3 Newton and 5 Newton acting at the same time to produce a resultant of 8. Resultant of 8 Newton. The angle between the forces may be, we have 1, 0, 1, 0, 2. The option 2 is 60, 3, 90, and the 4, 180. Either, what is the correct option here? Either.
Sir,
What's the correct answer here?
I got 5 Newton. 4 Newton.
You got 4. Did you look at the question? No. The question demands the angle between the forces. Okay, let me still explore. Yasmin, what's your answer? Yasmin, what's your answer? Anybody? The gentleman, anybody? What will be the answer? What will be the angle between the forces? Helium.
0 degrees.
That's 0. So 0 is correct, meaning that the two forces are what? What will be the relationship between the two forces?
Parallel.
They are parallel. Exactly. So 47, the answer is 0. 48. 48. A table exerts a 2 Newton force. Either mute yourself. A table exerts. Alikem, what's your hand is up?
I'm sorry, it's a mistake.
A table exerts a 2 Newton force on a book lying on the Godfred. Godfred.
Sir, please, I just joined. Please, what are we learning?
We are answering the questions I posted on the platform. Okay, so go to the platform. I forwarded some questions earlier. So a table exerts a 2 Newton force on a book lying on the table. The force exerted by the book on the table must be 20, 2, 0.2, and 0. Yes. What is the correct answer here? 48. Please, if you are ready, quickly share your view and let's move on. What force is exerted by the book, the book on the table? Elikem again.
2.0 Newton.
Why? Why do you think so? Why 2.0? Can you explain? Okay, Ida.
Yes, sir.
Sir, please, I want you to go over the 47 again.
Okay, you don't worry. Let's answer 48 and I'll go back. Okay.
Okay.
What's your reason, Elikem?
Sir, please, the book is exerting a 2.0 Newton force on the table, and Newton's theory of motion says that for every action there's an equal and opposite reaction.
Okay.
So the table also exerts a 2.0 Newton upward force on the book. This force is what supports the book against gravity.
All right. So it's true. The answer must be 2.0. The reason is that once the book does not move and is in equilibrium on the table, okay, then it means that the total forces acting on the book in all directions must be equal to 0. Okay, the total resultant forces acting on the book from all directions must be equal to 0. So if the book is exerting a weight of 2 Newton onto the table, then the table must exert equal and opposite force on the book so that the net force or the resultant force on the book will be 0. So that's the reason. Now, 47. Either a force of 3 Newton and a force of 5 Newton, okay, act concurrently to produce a resultant force of 8. So 3 Newton force and 5 Newton force, okay, act to produce a resultant force of 8 Newton. What will be the resultant? What this means is that if the resultant force is 8, then it's like adding the 3 Newton to 5 Newton to produce a resultant of 8. And when we have two forces and they are acting along the same direction or they are parallel to one another, the resultant is equal to the summation of the individual forces. So F1 plus F2. Okay. And when we sum forces, because they are parallel lines have an angle of 0 between them. When two forces or lines are parallel, then it means that the angle between them must be 0. So that is the reason why. Okay. 49. The diagram at the right. Okay, I think 49 appears at the next page. So let's move to the diagram at the right. I'm coming. The diagram at the right. Oh, okay. Sorry, it's not like that. Okay. Look, I'm coming. The diagram at the right represent two concurrent forces acting on a point. Which vector best represents their resultant? Which vector here? 1, 2, 3, 4. Which of them best represent their resultant? Frank.
Certainly the second one. Certainly the second one.
You mean the second one?
Yes.
More views. Yes. More views. Frank has given us his opinion. More views.
The second one.
Hey, Giovanni.
That is the fourth one.
Giovanni is going for the fourth one. And then Gideon went for the third one. Anita and Co, let me hear from you.
Sir, please.
Okay, Augustine is also going for the fourth one. Anita, the fourth one. Okay, so my view, the resultant force must be equal to the fourth one. The answer is the fourth one. Giovanni, your hand is still up. Okay, question 50. So maybe a quick illustration as to why it is the fourth one. So we have this one in this direction, and we have this one directed due east. So before we can find the resultant, we must resolve it into a shape of a parallelogram. So using equal vectors, we have this in this direction. Then we equally have this along this direction. So we have this downward direction, this horizontal direction. So Looking at it from above or below, the resultant can be drawing a vector from here to this. And that is represented by the fourth one. Okay, 50. 50. The resultant of two forces acting on the same point at the same time will be greatest when the angle between the forces is, listen to the question again. The resultant of two forces acting on the same point at the same time will be greatest when the angle between the forces is, yes. So when we have two forces acting on the same point at the same time, which angles here would give us the greatest force? What must be the angle between the two vectors so that we can have the greatest force? Must it be 0, 45, 90, 180? Yes. Yes. Let me pick views. Augustine is saying 0. Yes, more views. When Tiwa and Co speak, oh, Miles, Michaela, Mary, Marilyn, the two Marilyns, Lordina, Koku Texan, Ella, Ohene, Nicole. Yes, which of the angles would give us the greatest force? Frank. 90. Okay, Frank is going for 90. Gideon.
90 degrees.
90. Giovanni.
Seb is 90.
Okay. Ladies, let me hear from you. The gentlemen are going for 90. Augustine went for 0. Anita, Emelda, Michaela, Blessing, Ella, 21. Okay, my view. Akosia.
So please, 0 degrees.
Akosia is going for 0.
There's 0 degrees.
Okay, 0. All right. I will also go for 0. This is the reason. Let's assume that the two forces F1 is 10, F2 is 20. I'm just assuming values. If they are 180, if the angle between them is 180 degrees, Emelda, what will be the resultant? If these are the forces and the angle between them is 180, what will be the resultant? Emelda. Okay, Anita, if the angle between them is 180, what will be the resultant?
So please, 10.
Okay, 10. If the angle between them is 90, what will be the resultant? Akosia, if the angle between them is 90, what will be the resultant? The gentleman, if you're also ready with the answer, you can share it with me. If theta is 90, if theta is 90, what will be the resultant? Anita, if you are ready, share with me. Akosia and Co. When you speak, Ella. Gideon, what's your answer if the angle between them is 90? Yeah, the silence, I don't like it. Anita, what's your answer? Giovanni.
Please, I got 22.
Okay, let's see. So when it's 90, we the resultant will be using Pythagoras theorem. So 10 squared plus 20 squared. So we have 100 plus 400. This is equal to square root of 500. What's the square root of 500?
10 root 3.
Come again. Come
Hey,
again.
10 root 5. 10 root 5.
10 root 5. What is 10 root 5?
22.360.
So
360.
22.36 Newton. So if it's 90, if it's 90, that's the answer. Okay. Then let's look at the other. I'm coming in. I need to answer this question. Let's look at the other angles. So we've done when it is 180, when it is 90. Now when it is 0, when theta is 0, what will be the resultant in this case? When theta is 0, what is the resultant?
30.
So here we have 10 plus 20. So we have 30. Then what's the last? When theta is 45, when theta is equal to 45, what will be the resultant? Yes, quickly, do that and then share it with me. When theta is 45, what will be the resultant? Valerie.
15
How did you get it, Valerie?
is the sum of the forces minus 45.
Sum of the forces minus 45. And Valerie, I'm not convinced. Valerie, I'm not convinced. So here, you see, the angle is acute. When the angle is acute or obtuse, use the cosine rule. Use the cosine rule. So the square of the resultant must be equal to f1 squared plus f2 squared plus 2f1 f2 times the cosine of the angle between them. So r squared here would be equal to 10 squared plus 20 squared plus 2 times 10 times 20 times cos of 45. 100 plus 400 plus cos 45 is root 2 on 2. So 10 times 20 times root of 2. The 2 will cancel the other 2. Okay, so 500 plus 200 times root of 2. Root 2 is 1.414. So multiply 200 by 1.414 for me, and then add it to 500. Let's hurry up. 200 times 1.414.
282.8.
282.8. Good. So this plus 500. We have 782.8. So R squared is equal to 782.8. So that R is equal to the square root of 782.8. What's the square root of this? Give me the answer in 2dp.
27.98.
27.98 Newton. So we've considered all the angles. Class, which of the angles is giving us the greatest resultant or the largest resultant force? Which of them? Which of them is giving us the greatest resultant force?
0 degrees.
0. So obviously, and which of them will give us the least resultant force?
180 degrees.
180. So please take note of that. If two forces or vectors are acting at a point concurrently, the greatest resultant force is when they are acting parallel to one another. The least resultant force will be when they are oppositely to one another. Is there any question? No question. Let's move on to the next question. So I think we are on 51. What is the magnitude of the vector sum of the two concurrent forces represented in the diagram? What is the magnitude of the vector sum of the two concurrent forces represented in the diagram? So we have two forces acting perpendicularly to one another. This is 2.0 Newton, and this is 1.5 Newton. What will be the magnitude of this? Valerie, are you there?
Yes, please.
Do this for me. 2 Newton, 1.5 Newton force are perpendicularly to one another. What will be the magnitude of these two forces? Of course, the answers are there. So when you are correct, I mean, you can definitely identify or see your answer within the options given. Valerie, hurry up, okay? Emelda, are you gone? Or she has network problem? Ella.
Please, the answer is 2.5 newtons.
Say please, it's 2.5 Newton.
2.5. Okay, so let's confirm. Once the two vectors or forces are perpendicularly to one another, then the resultant will be determined using Pythagoras theorem. So 2 squared plus 1.5 squared. And this is 4 plus, what is 1.5 squared? What is 1.5 squared? Ella.
So that's 9/4.
Your final answer?
2.25.
That is 2.25. Therefore, when you sum this, you have 6.25. What's the square root of 6.25? Square root of 6.25.
2.5.
2.5 Newton. Okay. So that's it. "52. The resultant of two concurrent forces is minimum when the angle between them is..." Ella, this is your question. The resultant of two concurrent forces is minimum when the angle between them is 0, 45, 90, and 180. Hey, Ella,
Sir, please, 180 degrees.
180 degree. Thank you. 53. As the angle between two concurrent forces, of 5 Newton and 7 Newton increases from 0 to 180, as the angle increases from 0 to 180, the magnitude of their resultant changes from 1, 0 to 35, 2, 2 to 12, 3, 12 to 2, and 4, 12 to 0. As the angle between two concurrent forces of 5 and 7 Newton increases from 0 to 180, their resultant also, the magnitude of their resultant also changes from... Anita, this is your question. The magnitude of their resultant also changes from...
Sir, please, I don't.
Anita, come again.
Sir, please, I don't know.
Okay, so listen to... As the angle increases from 0 degree to 180, the magnitude of their resultant also changes from... Yes, the gentleman. Let me hear from you. Hey, Gideon and Co. Isaac.
The 12 to 0.
You said 12 to... Don't forget, the forces are 5 and 7. So as the angle increases from 0 to 180, Yasmin, what's your answer?
So I said 12 to 0.
12 to 0. Frank. Okay. The magnitude of their resultant also changes to 12 to 2. 12 Newton to 2 Newton. Now, when the angle between them is 0, the resultant is equal to 12. When the angle between them increases from 0 to 180, the resultant between them is 7 minus 5, and that is 2 Newton. So the answer must be the magnitude of the resultant will also change from 12 to 2. So that's the third answer. Anita, are you okay?
Yeah.
All right. 54. Two concurrent forces act at right angles to each other. If one of the forces is 40 Newton, if one of the forces is 40 Newton, we are told that they act at right angles to one another. If one is 40 and the resultant of the forces is 50 and their resultant is 50, the magnitude of the other force must be, so it's like two forces that are at right angle to one another. One is known. F1 is 40. F2 is not known. F2 is unknown. However, you are told that their resultant is equal to 50. What will be the second force? What will be the second force? Yes, anybody to share what he or she obtained with me? What will be the second force? Anybody? Free will. Valerie.
Is 30 newtons.
Valerie, how did you get it?
Please, I use Pythagoras.
Okay. Okay, let's see if Valerie got it right. So, once they are perpendicular to one another, R squared is equal to F1 squared plus F2 squared. R is 50. So 50 squared is equal to F1 is 40. F2, which is unknown. Therefore, F2 squared is equal to 2,500 minus 16,100. This is equal to 900. F2, therefore, is equal to the square root of 900. And it is 30 Newton. Valerie got it right. Application of vectors. Very, very, very important. Okay. $55, the last question. If two 10 Newton concurrent forces have a resultant of 0, the angle between the forces must be either, this is your question. If two 10 Newton concurrent forces have a resultant of 0, the angle between them must be, between the forces must be equal to what? Either. Or either is not you. Valerie. Valerie. Okay, Elika, go ahead.
180.
It must be 180. Okay. It must be 180. So that's it. Okay, let me see by hands those of you who scored everything.
Sir, please, can you explain?
I'm coming. I've said this over and over. We have two 10 Newton forces. F1, F2. They are acting at a point. If you have two forces that are opposite to one another, then it means that the angle between them is 180. Under this circumstance, the resultant force is the difference between the forces. So if we have two, if they have the same magnitude, 10 Newton, then obviously the angle between them, their resultant must be 0 Newton. And if the resultant is 0, then the angle between them must be 180. Okay. For this, we've done it over and over. So if you have any question, quickly ask. If you have any question. Okay. Then let's continue our discussion on what we were doing last time. Okay. And the resolution of vectors. So all these are limited to when you have just two. If there are three, Pythagoras theorem, adding them, subtracting the lesser one from the larger one, or using cosine rule. If there are three, you cannot. So if there are three or more, then you must resolve the vectors into components and then only to determine or use the resolution of vectors to determine the resultant. Alikem.
Sir, please, I have a question.
Okay. Reposition. Your line is breaking. Okay, go ahead.
Sir, can you hear me?
Yes.
Sir, I said I have a question. I want.
Okay.
Sir, please, for the two times F1 times F2, is there supposed to be a plus sign or a minus sign?
Oh, go for it. Hey, Alikem, I explained that. And I even derived this formula with you. It seems you have forgotten.
Please,
Your line is breaking.
I wasn't.
You wasn't home.
I wasn't able to join all the classes because of the day.
All right. So I'm quickly.
I said I was not able to join all the classes.
Okay, you don't worry. It can be a general problem to all of you. So let me quickly address that. So we have two vectors. This. So this is when the angle between them is an acute angle. Something greater than 0, but less than 90. So this is theta. So F1, F2. To determine their resultant, you must use a parallelogram law of vectors. Resolve it to form a parallelogram. In realigning their directions. So we have the shape of the parallelogram. So if because this side is equal to this is also F2. This is F1. Okay, then we can say that the direction of the resultant is drawing a vector from the tail of F1 to the head of, from the tail of F2 to the head of F1. Something like that. Okay, so okay, their directions also obey the triangle law of these two can be represented as the size of a triangle. Then, because this one and this one are parallel, parallel lines have the same slope. So the angle between F1 and then the x-axis extended, the x-axis or the east. If this angle is theta, then this angle here must also be theta. Elikem, if this angle is theta, what will be this angle? What will be this angle, Elikem?
180 minus theta.
So 180 minus theta. Okay. And last time we derived this and then saw that we can also use Pythagoras theorem also to determine the same resultant force. So O, A, B, C, D. If we use triangle D, B, C, the opposite is equal to F1 sine theta using this angle, the angle with separating the forces. And this component would also be F1 cos theta. Then when we consider the triangle OBC using Pythagoras theorem, we realize that OB squared, which represents the resultant or the hypotenuse of that triangle or of that right angle triangle, will be equal to BC squared plus OC squared. We expanded BC. BC is F1 sine theta, the squared, plus OC. OC is F2 plus F1 cos theta, also squared. In fact, OC is actually OD plus DC. And OD is F2, DC is F1 cos. That is how come we got this. So we expanded this and then got F1 squared sine squared theta or sine theta squared plus F2 squared plus 2 times F1 times F2 times cos of theta plus F1 squared times cos squared theta. This is the expansion. Then we group like terms F1 squared sine squared theta plus F2 squared plus F1 plus f1 squared times cos squared theta. That is grouping of this and then this one. Okay. Then plus f2 squared. Then the remaining term, which is 2f1, f2 cos theta. We factorize out f1 squared, and we have sine squared theta plus cos squared theta plus f2 squared plus 2f1 f2 cos theta. Because whatever sine squared plus cos squared is equal to 1, we have f1 squared plus f2 squared plus 2f1 f2 cos theta. And this is OB. OB is the resultant. Therefore, the resultant is equal to the square root of all these. And this is the cosine rule. Now, you can use theta, which is the angle between them, and 180 minus theta is the corresponding acute angle. Okay, let me clear this side to explain when do we use the corresponding acute angle. Okay. Now, cos theta, this cos theta here, this cos theta, cos of the acute angle, can also be obtained from when we take cos of the obtuse angle 180 minus theta. This is because if I want to expand this is cos 180 times cos of theta plus sine 180 times sine of theta. Cos 180 is equal to, the expansion of this one. Cos 180 is equal to -1. So -1 times cos theta. Sine 180 is equal to 0. So this is plus 0, meaning that cos 180 minus theta is equal to negative of cos theta. Meaning cos theta is equal to negative of cos 180 minus theta. So, Elikem, are you here?
Yes, sir.
Meaning that this cos theta, because from what I've just heard, because cos theta is also equal to negative cos of 180 minus theta, I can also, in place of cos theta, I can substitute the negative cos of 180. So if I want to use the corresponding obtuse angle, okay, then the substitution will be r squared is equal to f1 squared plus f2 squared. This is plus 2f1 f2. But what do I have? I now have cos theta to be equal to negative cos of 180 minus theta. Meaning that I can also represent this same formula by F1, F2 squared, negative times positive to give me minus 2F1, F2 cos of 180 minus theta. That is the second formula. And this must give you the same value as when I use just cos theta. If I use cos 180 minus theta, it means that I'm using the corresponding obtuse angle. So if theta is 60 degrees, cos of 60 is also equal to negative cos of 180 minus theta, 180 minus 60, which is 120. So what cos 60 can do, negative cos of 120 will do the same thing. If you give me 30 degrees as the angle between the forces, cos of 30 must also be equal to negative cos of 150. Are you okay? Elikem, are you okay?
Yes, sir.
If you give me, if the angle between the forces is 180, cos of 150, cos of 150 must be equal to negative don't forget this is obtuse. Okay, this is obtuse. So this must also be equal to cos of 30. So whether you are giving acute or obtuse, you must be able to connect and get it right. Elikem, are you fine?
Yes, sir.
All right. Please, is there any question? Anita?
Sir, please, I would like to know why cos 180 minus theta is equal to cos 180 times cos theta plus sine 180 plus.
That's a formula. We have formula for trig ratios. If you have this is compound angles. Compound angles is about when you are expressing trig ratio of two different angles. And I think I explained. So when you have two separate angles such as A and B, the cos of the compound angle A plus or minus B, depending on what you want, is that if it is plus, if the angle between, if the operation or the operator between the two compound angles is addition, then the formula or the rule is saying that the expansion of this is cos of A times cos of B minus here. Once there's a plus here, when you expand, it will be minus. Once there's a minus, when you expand, it will be plus. So cos A cos B minus sine A sine B. And if it is minus, the expansion will be cos of A cos of B plus sine of A sine of B. We have the same thing for sine. We have it for tangent as well. So Anita, this is a formula. It's a formula. Are you okay?
Yes.
As you grow in physics and math, elective maths, you will be taught. So don't worry. For now, I'm just applying it. Okay. So a kind of revision for you. So the sine rule, cosine rule, Pythagoras theorem, adding them when it's zero is limited. The limitation is that they are applied to when you have two vector quantities acting concurrently at a point. If you have anything more than that, the rule is different. And that is what we can determine using the method of Hey, Augustine. Augustine,
Yes, sir.
you are taking me back again. Okay, class, let's address. Augustine is interested in one of the questions we solved. Okay, so class, let's exercise patience and then help ourselves. I think once it's a problem to him, it's equally a problem to others as well. So when it comes up, let's be patient and address it. Okay, so his interest is about this question. 3 forces, 9 Newton, 12
Sir,
Newton.
please, I've seen it. It's okay.
Are you fine?
Yes, please.
Okay. So we have when we have the forces acting in different directions. Please give me the example, the question on what I asked you to do last week. I actually gave you the question during the online class, did not paste it. Or let me create, I can also create forces to do that. So you don't worry. So let's assume that we are given 3 forces acting. This is acting. This has a magnitude of 15 Newton. Acting due east. We have another one acting at an angle of 45 degrees to this direction. This is 25 Newton. This is 45. Then we have a third one of magnitude 30. The angle it makes with the x, as this is 30 degrees. The question demands that we find the resultant of these 3 forces and their direction. So determine the resultant. This is minus y. Okay. So something like this. So because these are 3 forces acting within the Cartesian plane, this one you cannot use cosine rule and the sine rule. So that is what I meant by the limitation of the sine rule and the cosine rule. We can only apply that to 2, But when we have 3 or more, we must use the method of resolution of vectors. So pick each one of them and then resolve it into its vertical and horizontal. So let's assume this is F1, this is F2, and this is F3. Pick F1. Anna, are you there? Apple. Pick F1, resolve F1 to its vertical and horizontal component. Okay. Resolution into column vector form, we are only asking that represent it so that it is, the component is expressed as X, Y in a column vector form. Column vector. Okay, so F1 has 0 vertical. Once this force is acting along the x-axis, it means it only has a horizontal component or x component and has no vertical component. Class, are you with me? Are you with me? Hello, are you there?
Yes, please.
Okay, so the component of this will be equal to 0x, 15 Newton x and 0y for F1. Okay, or if you want to go by formula, if you want to use the angle it makes with the horizontal or x-axis, the angle here in this case is 0. It makes an angle of 0 with the x or the horizontal. So in that case, resolving it will be F1 cos 0, the angle it makes with the x-axis, and then F1 sine 0. I explained this to you last time. So it means that if you want to go by formula, then the x and y components of this will be equal to 15 times cos of 0 and then 15 times the sine of 0. Cos 0 is 15. Cos 0 is actually 1. So 1 times 15, we have 15. And then sine 0 is 0. 15 times 0 is 0. So it brings us back to the same thing I earlier said. Another way out is that you can use the angle it makes with the y-axis. And if you use the angle, this vector, 15, F1 makes with the y-axis, the angle in question is 90 degrees. Okay. Do not forget that if you want to use the angle it makes with the y, the order of the column becomes F1 sine of the angle 90, then F1 cos of the angle 90. And I taught you this, that's why I'm not going over it into details. So F1 is 15, sine 90 is equal to 1, cos 90 is equal to 0. So 15 times 0. So we have the same thing, 15, 0. So these are the components of F1. Then pick F2. F2, the resultant is 25 Newton. Okay. You can use the angle it makes with the X or the Y. If you want to use the angle, the force or the vector makes with the X-axis, then you have F2 times cos of the angle 45. But within this quadrant, x is negative. Okay, x component is negative. This is the y component. And then this is the x component. So within this quadrant, x is negative. So bring the negative here. Then the y component, within the same quadrant, y is also negative. Negative y. So minus f2 sine 45. Giving us Giovanni.
We should make F2 10.
I made F2.
It's okay, I misread it.
Okay, so being equal to negative 25 cos of 45. And then negative 25 sine of 45. Cos 45 is root 2 on 2. So this is minus 14.5. Network is disturbing my right. I'm coming. Minus 14.5 root of 2. You can also express it in decimal. And then the y component will also be the same. Minus, is it 40? No, that is 12. 12. Please, I'm doing this with you. Do not, if you see a mistake, let me know. Okay. Okay, let me take my time and then go through this with you. So minus 25 sine cos 45 is root of 2 over 2. Gideon.
So because I thought if you use the angle, it will be rather sine cos, not cosine.
The angle it makes with the x is 45. So if you are using the angle it makes with the x, it's cos sine. And that's exactly what I've done here. If you use the angle it makes with the y, it will be sine cos. Okay, here, because the angle is 45, the value will be the same. Gideon, are you okay?
Okay. Yes, sir.
Okay, so if you multiply this through by 12 divided by 2, 25 divided by 2 is 12.5. So minus 12.5 root of 2. You can later change it to decimal. And the same value minus 12.5 root 2. So for F2, these are the components. Okay. The other way out is that you can use the whole angle it makes with a positive y. This whole angle. Okay. And this whole angle from the north or positive y will be equal to 180 plus 45. 180 plus 45. And 180 plus 45 is 225 degrees. So if you are using the angle it makes with the x with the y, then it can be 25 sine 225. Then 25 cos 225 degrees. Please, if you use the whole angle from the north, you do not include the quadrants. You do not look at which quadrant the vector is within to decide its x to be negative or its y to be negative. Here, the angle will cater for itself. So if you are using the whole angle, do not look at the quadrants as to whether x will be positive or negative. The whole angle will cater for itself. Yes, Gideon.
Sir, please, if you are using the whole angle, please will it be sine cos?
Yes, because we are taking the angle from the y-axis. Y-axis. Anytime you take the angle from the y-axis, it's a sine cos. If you take it to the x-axis, it is cos sine. All right. So when you punch this, you get the same value as whatever I've had here. Confirm it for me. Punch it and then give me the feedback. Do not forget to leave your answers in sets. Anita, give me feedback. What is your answer? Oh, Anita is not there.
Yep.
Gideon, hurry up. Anita, hurry up. Oh, you don't even have a calculator. Gideon, what's your answer? Gideon.
Sir, please, I'm coming. I'm punching into the calculator.
Please, when we are doing this, do not waste time. You are just to input values. And somebody must also be a standby so that if there is network issue with one person, you can also take over. So we save time.
Please, I got the same answer.
So you must have the same results. Okay.
Yeah.
But the question is, what have been spelled out to you? If you are using the whole angle from the north, you shouldn't look at the quadrants. Just go ahead and use it. Okay. So let's also look at F3. F3. F3, if you are to use the angle it makes with the x-axis, the quadrants or the components will be F3 cos of 30, but you must check the quadrants. It falls within the second quadrant. Over here, x is negative. So minus that, giving us, then the y component will be F3 sine of the same angle. Within this quadrant, the y component is positive. Y component is positive. So negative 30 cos of 30 degrees, then 30 sine of 30. Cos 30 is root 3 on 2. So we have negative 15 root of 3. Sine 30 is half times 30. So 15. The other plan B is that you can use the angle it makes with the y. This is 60. And if you use that, the other will be sine Gideon. The other will be sine cos. Are you okay?
Sir, please. I thought it would be cosine since the angle we made to the x-axis is 30 degrees.
Gideon, listen to me. We have used the angle it makes with, oh, you are not following. We just discussed the angle it makes with the x-axis, and it is 30. Or you were not observing. So using the angle it makes with the y, we have 30 sine 60 within this quadrant. Within this quadrant, Will the x component be negative or positive? Within this quadrant, would x be positive or negative? So minus. Then the y component will also be 30 cos 60. And that is positive. Giving us sine 60 is root 3 on 2. So negative 15 root 3. Cos 60 is half, giving us 15. The same value as the angle it makes with the x axis. We can also use the whole angle from the positive y or the north, and that will be this whole angle, 180 plus 90, which is 270. So this is 180 plus 270 plus 30 degrees. What is 270 plus 30?
200.
Anita.
300 degrees.
So that is 300. So we can also have the same component using 15. The force is 30. So 30, this time, because we are taking the angle from the positive y, okay, sine of the whole angle, which is 300, then 30 cos of 300. The caution is that if you are using the whole angle from the north, you do not look at the quadrant. Anita, what is sine 300? Give me your answer in search form. Sine 300.
Negative 300.
Negative what?
Root 300.
So giving us minus 15 root of 3. And cos 300. Anita, what is cos 300?
How?
Giving us 15. Frank, your hand is up. All right. So the value is the same. Now, after getting the component, you look for, let's quickly finish this. Summation of all fx. Pick x in 1, x component in 1, plus x component in 2, plus x component in 3. X component in 1 is 15. X component in 2 is 12.5, negative 12.5 root 2. So 15 minus 12.5 root of 2. Then x component in 3 is also negative. Minus 15 root 3. So minus 15 root of 3. Please simplify this for me. Change 12.5 root 2 to decimals, and then 15 root 3 to decimals as well. So 12.5 times root 2. Give that to me in decimal. Yes. You people and time wasting.
Minus 17.67.
Minus 17.6.
0.67.
Let's make it 6.8. Okay. Then 15 root 3. 15 root 3.
25.9.
We are expressing our values in 2 in 2 decimal place. So 25.98. Okay. So sum it up for me. Sum everything up for me.
Negative 28.66.
Negative 28.66 Newton. Confirm it for us.
Sir, please, I got the same answer.
Okay. So these are the summation of f of x. Let's look at summation of f of y. So pick f1y plus f2y plus f3y. Let's go back. f1y is equal to 0. f2y is negative 12.5 root 2. And f3y is 15. Okay, so 0, negative 12.5 root 2 and 15. So let's put everything together. 15 minus 12.5 root 2. 15 minus 12.5 root 2. Yes, what's the answer?
Negative 2.68.
2.68 Newton. Let me check on your messages quickly. And then okay. I think you were doing the same thing. Okay, so after resolving the forces into the various components. So please, the trick is that no matter the number of vectors or vector quantities acting in different directions, pick each one at a time and resolve it into components. When you finish, sum up all the x's, all the y's, and then the next thing is this. Redraw summation fx and summation fy on the Cartesian plane. The Cartesian plane is the xy axis. So a quick sketch. This is x. Imelda, are you there? Daisy. Hey. Okay. So summation f of x is along the negative. It's a negative value. So we'll place this along the negative x-axis. This is 28. Here we are going to write the magnitude because we have already taken care of the direction. So 28.66 Newton. Then summation Fy is also negative. So we put it here. And its magnitude is 2.68 Newton. The question is that, maybe somebody's question is that, sir, why didn't we consider the negatives? We did not consider the negative because we've already taken care of it. Okay, it is because of the negative, that is why we did not place it here. We did not place it in this direction, and then the y in the upper direction. But we represented the x, okay, due west, and then represented the y due south. So we've taken care of the negative as well. Class, are you okay?
Yes, please.
All right. So what will be the resultant? Of course, when two vector quantities, one is directed due south, due west, and another one is directed due south, of course, the resultant will act along the diagonal. So it will be directed here. It will be directed here. It will be directed along the diagonal. If you want to use realign their direction to get it will also give you the same thing. Okay, equal vectors. When you draw equal vectors, you have a vector equal. So this is also summation f of y. And so the resultant would actually, so this will be the direction. Since the two are perpendicularly to one another, we can find the resultant using Pythagoras theorem. So R, the square of the resultant, will be equal to summation of the square of x plus summation of the square of y. Gideon, are you there?
Yes, sir.
Okay. So summation f of x is 28.66 squared plus summation f of y is 2.68 squared. Put them together and then give me a final value for R. Okay, so let somebody confirm it for us. Ella and Co. Ella, Yasmin, Ida, you are all fine. What's the final answer for the resultant?
28.78.
28.78. That's the result. Then direction. Direction, if I'm at the north and I want to face this, how much do I turn to face the direction of the resultant? So obviously, this whole angle from north to south is 180. If I could determine this, I can subtract this from 90 to get the direction from the north. So let's first determine theta. Once we have the opposite, we have the adjacent. Tan of theta is equal to the opposite, which is summation f of y over summation f of x. Summation fy is 28. Is 2.68. Summation f of x is 28.66. Give me the ratio. 2.68 divided by 28.66.
0.09.
0.09. Take the tan inverse of this. So tan inverse of 0.09.
5.14.
5.14. Approximately 5 degrees. Okay. So what it means is that this small angle to the west is 5 degrees. So if I'm here, if this is 5 degrees, what will be this angle? If theta is 5, what will be this angle here? That will be 85. So the direction of the resultant from the north will be equal to 85 plus 180. 180 plus 85. This is 265 degrees. So if you are at the north and you want to face the direction of the resultant, it means you must turn through an angle of 265 degrees. Okay. So the angle is actually 265 north of northwest. Or north south rather. Okay. To get the direction of the result. Or turn through an angle of 5 degrees from the north, from the west. Okay. In an anti-clockwise manner. So if you are at the west, turn through an angle of 5 degrees anti-clockwise. Then you face the direction of the north. So either you go by this or you pick it from the nearest axis or cardinal. That's the direction. Please, is there any question? Okay, we have 4 minutes. So please, with this method of resolution of vectors, it doesn't matter the number. Gideon.
So here, the direction is 265 degrees north.
From the north, bearing, once it's 265, it means you must measure from the north. Don't forget, in bearings, angular measurement is taken from the north. So when you talk about 265, then you must measure from the north. 5, you must measure from the west. Are you okay?
So when you use the
Gideon, hurry up.
from the north theta.
I don't get your question. Your line is breaking.
So when you get your value for theta, are you supposed to calculate the 180. How
What
will
I'm
you know that?
what I'm saying is that in bearings, angular measurement is taken from the north, isn't it? Gideon, isn't it?
So, please, I didn't hear what you said.
I said in bearings, angular measurement is taken from the north, isn't it? Okay, you send me a message after the class to answer your question. Your line is breaking. Please, class, do you follow what I said earlier?
Okay, sir.
I'm talking to the general class. Do you follow the explanation on the direction earlier?
Yes, please.
Okay. So the next thing we will look at is equilibrium. Equilibrium. The equilibrium of forces. We've done resultant. We'll look at the equilibrium, how to determine the magnitude of the equilibrium and then the direction as well. That will be done on Thursday. Okay, so I'll give you an example to try your hands on and then send it to me. Is that okay for Mark? All right, so our time is up. We end now and then we'll continue on Thursday. May the good Lord be with you, guide you, and bye-bye.
Bye.